See, transformed equations. Transformed equations means changed equations. Say for example, suppose alpha comma beta are the roots of ax square plus bx plus c is equals to 0. Then what is the quadratic equation having roots 1 by alpha comma 1 by beta? Okay, this is the question. Means how the equation will be changed. Usually alpha comma beta are the roots of this equation. We know very well that alpha plus beta, alpha plus beta is equals to minus b by a, alpha beta is equals to c by a given already. Okay, as alpha comma beta are roots of this equation. Now let us try to form a quadratic equation whose roots 1 by alpha comma 1 by beta. What is the quadratic equation having roots alpha and beta or gamma and delta? We know very well that required equation x square minus of 1 by alpha plus 1 by beta into x plus 1 by alpha into 1 by beta is equals to 0. This is x square minus of alpha plus beta by alpha beta into x plus 1 by alpha beta is equals to 0. Nothing but alpha beta times x square minus of alpha plus beta times x plus 1 is equals to 0. See, alpha beta c by a x square minus of alpha plus beta minus b by a x plus 1 is equals to 0. After simplification we get cx square plus bx plus a is equals to 0. But it is not looking like ax square plus bx plus c is equals to 0. In order to convert into that form, whole equation divided by 1 by x square on both sides, cx square by x square will be c, bx by x square b by x, a by x square, rewrite a into 1 by x whole square plus b into 1 by x plus c is equals to 0. Okay, finally what we can conclude, if alpha comma beta are the roots of any equation, let it be f of x is equals to 0, then 1 by alpha comma 1 by beta are the roots of f of 1 by x is equals to 0. Means required equation is obtained by replacing x by 1 by x in the given equation. Okay, same concept in other words also we can discuss. Given that alpha comma beta are roots of ax square plus bx plus c is equals to 0. Okay, we have to form a quadratic equation having roots 1 by alpha comma 1 by beta. Put x is equals to 1 by alpha. Let any one of these given roots as x. From this, alpha is equals to 1 by x. Yes, we got alpha value. As we know, alpha is a root of this equation. We are having alpha is a root of this equation, means a alpha square plus b alpha plus c is equals to 0. Since alpha is equals to 1 by x, we get a into 1 by x whole square plus b into 1 by x plus c is equals to 0. This is required equation. So finally we can conclude that if alpha comma beta are the roots of whichever the equation f of x is equals to 0, then the equation having roots 1 by alpha comma 1 by beta is f of 1 by x is equals to 0. So this is the conclusion. Okay. Similarly, we can write some more transformed equations. So let us see. See, if alpha comma beta are the roots of f of x is equals to 0, then the quadratic equation having roots number 1 by alpha comma 1 by beta is, just now we have seen f of 1 by x is equals to 0. Means whichever the equation is given, required equation is obtained by replacing x by 1 by x. Number 2, minus alpha comma minus beta is, see, in order to find the required equation, put x is equals to minus alpha as in the earlier case. X is equals to minus alpha, find out alpha value from there, alpha is equals to minus x, substitute in this equation, we get f of minus x is equals to 0. Alpha plus k comma beta plus k is, see, for this put x is equals to alpha plus k, alpha is equals to x minus k. Substituting alpha in the equation f of x is equals to 0, because alpha is a root of this equation, we get f of x minus k is equals to 0. Simple logic. Alpha minus k comma beta minus k will be, put x is equals to alpha minus k, find out alpha from there, we get x plus k. If you don't like it, put x is equals to beta minus k, find out beta from there, we get x plus k, substitute in this, f of x plus k is equals to 0. Number 5, k alpha comma k beta is f of, put x is equals to k alpha, find out alpha from this, we get x by k, f of x by k is equals to 0. Alpha by k comma beta by k is, x is equals to alpha by k, alpha is equals to kx, that's why it is f of kx is equals to 0. Okay. Next, 7th result, alpha square comma beta square is f of root x is equals to 0, because x is equals to alpha square, alpha is equals to root x. 8th case, alpha cube comma beta cube is f of cube root x is equals to 0. Do observe that required quadratic equation obtained by eliminating square root from this equation, eliminating cube root from this equation. Next, number 9, alpha power n comma beta power n will be f of nth root x is equals to 0. 10th one, p alpha plus q comma p beta plus q is, try to tell this, put x is equals to p alpha plus q, x is equals to p alpha plus q, alpha is equals to, bringing q this side, x minus q by p, alpha value substitute in this, we get f of x minus q by p is equals to 0. X minus q by p is equals to 0. So these are the transformed equations. Let us discuss few examples related to this. Okay. See one example. If alpha comma beta are the roots of 2x square plus 3x plus 5 is equals to 0, then the quadratic equation having roots alpha plus 2 comma beta plus 2. Just now we have discussed, let the given equation be f of x, that is 2x square plus 3x plus 5 is equals to 0. Its roots are alpha comma beta. Okay. Now quadratic equation having roots alpha plus 2 comma beta plus 2 is f of x minus 2 is equals to 0. You remember the formula, or else put x is equals to alpha plus 2, alpha is equals to x minus 2, replacing that. So we get 2 into x minus 2 whole square plus 3 into x minus 2 plus 5 is equals to 0. Expanding this 2 times, x square minus 4x plus 4 plus 3x minus 6 plus 5 is equals to 0. Therefore 2x square minus 8x plus 3x minus 5x plus 8 plus 5 13, 13 minus 6 plus 7 is equals to 0. This is by using the formula. మళ్ళీ చేపలు పట్టేవాడు ఇస్తే మనము తిన్నట్టు. సో మనమే చేపలు పట్టుకోవడం నేర్చుకుంటే అంటే ఏమంటున్నా చూడండి. సేమ్ let f of x is equals to given equation. For this equation, alpha is a root means f of alpha is equals to 0. Beta is a root means f of beta is equals to 0, given in the question only. In order to find a new quadratic equation with roots alpha plus 2 and beta plus 2, put x is equals to alpha plus 2, alpha is equals to x minus 2. As alpha is a root of this equation, in place of alpha we have to write x minus 2. That is 2 times of x minus 2 whole square, 3 times of x minus 2 plus 5 is equals to 0. F of x is this much. F of x minus 2 will be, x is replaced by x minus 2. After the simplification, we get 2x square minus 5x plus 7 is equals to 0. So dead easy concept it is. Okay. Next example, one more. See, next example. If alpha comma beta are the roots of x square plus 2x plus 5 is equals to 0, then the quadratic equation having roots alpha square comma beta square. Okay. See, whichever you like, formula based or concept based. F of x is equals to x square plus 2x plus 5 is equals to 0. Roots are alpha comma beta already given. Now the quadratic equation with roots alpha square comma beta square is f of root x is equals to 0. F of root x can be found by writing in place of x is root x in the given equation. We get root x whole square plus 2 times root x plus 5 is equals to 0, which is nothing but x plus 2 root x plus 5 is equals to 0. But it is not quadratic equation. Our aim is to write quadratic equation. In order to get quadratic, we have to eliminate square root from this. X plus 5 is equals to minus 2 root x. Squaring on both sides. We get left hand side x plus 5 whole square. Right hand side minus 2 root x whole square. So this is x square plus 25 plus 10x is equals to 4x. Therefore x square 4x bringing this side 6x plus 25 is equals to 0. Very simple, but extra part is to eliminate square root from this. Even though transformed equation having roots as cubes of those of given equation, in that also we get cube root. We have to eliminate cube root from that equation by applying the operation cubing on both sides. Okay, let's go to next question. See the next question. The quadratic equation whose roots are reciprocals of those of 5x square minus 9x plus 23 is equals to 0. Once again, find the quadratic equation whose roots are reciprocals of the roots of the given equation. Try to understand the question first of all. Suppose the roots of given quadratic equation are alpha comma beta. You find another quadratic equation whose roots are 1 by alpha comma 1 by beta. Okay, so that is the concept here. Let us assume given equation is f of x, its roots are alpha comma beta. Now the quadratic equation with roots 1 by alpha comma 1 by beta is f of 1 by x is equals to 0. That is 5 times 1 by x whole square minus 9 times 1 by x plus 23 is equals to 0. After the simplification we get 23x square minus 9x plus 5 is equals to 0. Simple. In the question did not mention the roots alpha comma beta 1 by alpha comma 1 by beta. So that is described through the word reciprocals of those of. Sometimes they will give the quadratic equation whose roots are equal in magnitude but opposite in sign, those of 5x square minus 9x plus 23 is equals to 0. Okay, see, equal in magnitude, opposite in sign means, suppose the given equation roots are alpha comma beta, required equation roots are with opposite signs, minus alpha comma minus beta. With opposite signs, they are also called additive inverses of the roots of given equation. They are also called with contrary signs of the roots of given equation. Contrary signs means opposite signs. When 5 comma 6 are roots of one of the equation, roots with contrary signs means minus 5 comma minus 6 are the roots of each equation. So that is the concept related to transformed equations. Let's go to another concept. My dear friends, Please like, share and subscribe my YouTube channel Srinivasa Academy for more videos, and to get full course regarding to your subject, your syllabus. Okay, please download the app Srinivasa Academy from Google Play Store. There you can see all videos related to your course.